When you first learn about vulnerabilities, it can feel like you are staring at an endless wall of problems, because every scan seems to produce more findings than any team could ever fix. That is where prioritization becomes the real skill, and prioritization is where threat intelligence and vulnerability data can help you focus on what matters most. The phrase threat intelligence can sound mysterious to beginners, but the basic idea is simple. It is information about how attackers behave, what they are targeting, and what methods are active right now. Vulnerability data is the information about weaknesses in your environment, such as what systems are affected and how severe the weaknesses might be. When you combine these two, you can move from fixing whatever is loudest to fixing what is most likely to be exploited and most likely to cause harm. The goal is not to predict the future perfectly, but to make better bets with limited time. This episode is about using these data sources to prioritize remediation in a way that reduces real risk instead of producing busy work. Start by separating two kinds of prioritization signals: internal signals and external signals. Internal signals come from your own environment and your own incidents, such as which systems are critical, which vulnerabilities exist on those systems, and what weaknesses have been exploited before. External signals come from the wider threat world, such as which vulnerabilities attackers are actively exploiting, which industries are being targeted, and what new attack techniques are trending. Threat intelligence is mostly an external signal source, while vulnerability data is mostly an internal signal source. If you rely only on internal signals, you might treat every vulnerability as equal because you do not know what attackers care about. If you rely only on external signals, you might chase dramatic headlines that do not apply to your environment. The power comes from combining them, because the highest priority issues are often those where external attacker interest meets internal exposure and internal criticality. For beginners, this is the key connection. Prioritization is about intersection, not about any single score or label. You want to fix what matters where you are, given what attackers are actually doing. Threat intelligence for prioritization does not need to be fancy, but it does need to be actionable. Actionable intelligence answers questions like which vulnerabilities are being exploited in the wild, what kinds of systems are being targeted, and what the typical attacker goals are. This is different from general news about cybercrime that may be interesting but not directly useful for remediation decisions. Actionable intelligence might tell you that certain exploitation techniques are common right now, or that certain categories of systems are being targeted because they are exposed and easy to abuse. The most valuable intelligence also includes indicators that a vulnerability is being used as an entry point or that it enables rapid spread. Beginners sometimes think threat intelligence is only about identifying a specific attacker group, but for remediation prioritization, you often care less about who and more about what. You care about whether a weakness is being targeted and whether your environment contains that weakness in a risky place. When you frame intelligence this way, it becomes a practical input to decision-making instead of an abstract report. Vulnerability data also needs careful interpretation because the raw list is not the same as risk. Vulnerability data can include severity ratings, affected assets, whether a vulnerability is remotely exploitable, and whether there is a fix available. It can also include context, like whether the affected system is internet-facing, whether it holds sensitive data, and whether it supports a critical business process. Beginners often assume severity labels alone tell you what to do first, but severity labels are only a starting point. A high-severity issue on an isolated system might be less urgent than a medium-severity issue on a system that is exposed to the internet and central to operations. Vulnerability data becomes far more powerful when it includes asset context, because prioritization is really about protecting what matters. Another key point is that vulnerability data can be incomplete or outdated if your asset inventory is incomplete, so improving inventory accuracy is part of improving prioritization. You cannot prioritize what you cannot see clearly, and that is why good data hygiene is a foundational step. To combine threat intelligence with vulnerability data, you can think in terms of three questions that guide prioritization. First, is the vulnerability relevant to current attacker behavior? Meaning, is it actively exploited or strongly associated with common attack pathways? Second, is the vulnerability present in your environment in a way that attackers could reach? Meaning, exposure exists through network access, user access, or dependency relationships. Third, If exploited, would it cause meaningful harm, meaning it affects critical systems, sensitive data, or core operations? When all three are true, the vulnerability becomes a top priority. When only one is true, it may still matter, but it might not be urgent. This mental model helps you avoid chasing noise and helps you explain priorities to leaders because it ties action to real risk drivers. For beginners, the important part is that prioritization is a reasoning process, not a magic number. You are building a defendable argument for why certain fixes come first. Another powerful concept is the difference between exploitability and impact, because prioritization often fails when teams focus on one and ignore the other. Exploitability is about how easy it is for an attacker to use the vulnerability in real conditions, including whether the attack can be done remotely, whether user interaction is required, and whether the environment makes exploitation simpler. Impact is about what happens if exploitation succeeds, such as system control, data exposure, service disruption, or privilege escalation. Threat intelligence often informs exploitability because it reveals which vulnerabilities are practical enough that attackers are actually using them. Vulnerability data and asset context often inform impact because they show what the affected system is and what it connects to. A vulnerability that is easy to exploit but low impact might be less urgent than one that is harder to exploit but catastrophic in impact if it occurs in a critical system. The best prioritization balances both because both drive real risk. For beginners, it is useful to practice explaining exploitability and impact in plain language because that is how you help stakeholders understand why certain fixes matter. You should also learn the idea of blast radius, which is the potential spread and damage that can result from a vulnerability being exploited. Some vulnerabilities are dangerous because they provide direct entry, while others are dangerous because they enable spread, privilege escalation, or persistence once an attacker is inside. Threat intelligence often reveals which vulnerabilities are used to move quickly within an environment, and vulnerability data reveals whether your environment has those weaknesses in places that would enable broad damage. Prioritizing based on blast radius is especially useful for risk reduction because it focuses on limiting worst-case outcomes. Even if you cannot prevent every initial compromise, you can prevent an initial compromise from becoming a major incident by fixing vulnerabilities that enable rapid expansion. For beginners, this is an important shift because it moves prioritization beyond the first door and toward the whole house. You are not only securing entry points, you are strengthening internal structure so a small problem does not become a disaster. Threat intelligence also helps prioritize by identifying which assets are likely to be targeted, not only which vulnerabilities are popular. For example, intelligence may indicate that attackers are targeting identity systems, remote access paths, and widely used business services because those offer high leverage. If your vulnerability data shows weaknesses in those same areas, that intersection becomes urgent. This is where prioritization becomes strategic rather than reactive, because you are aligning remediation with attacker incentives. Attackers often choose targets that maximize access and minimize effort, so vulnerabilities in high-leverage systems tend to be more dangerous. Even without naming any specific tool or product, you can understand that certain system roles, like authentication gateways, file repositories, and management platforms, tend to create higher risk when vulnerable. Your remediation strategy should reflect that by prioritizing vulnerabilities on high-leverage assets. For beginners, the takeaway is that not all assets are equal, and threat intelligence can help you understand which types of assets attackers care about most. A crucial part of using intelligence and data responsibly is avoiding the trap of false precision. It is easy to treat a score, a rating, or a colored dashboard as absolute truth, but these are models, and models can mislead. Intelligence may be incomplete, and vulnerability data may be wrong or missing context. Attackers can also change tactics quickly, so what is hot today might cool down tomorrow. The solution is not to ignore these inputs. It is to treat them as decision support rather than as decision replacement. You can improve confidence by cross-checking sources, by validating exposure, and by verifying asset criticality. You can also maintain a small set of stable priorities based on your environment structure, even as tactical priorities shift based on intelligence. For beginners, it helps to think of prioritization as a combination of stable risk drivers, and changing threat signals. The stable drivers include which systems are critical and exposed, while changing signals include which exploitation patterns are active right now. Another important connection is that incident outcomes should feed back into your intelligence-driven prioritization. If your organization experiences an incident involving a certain type of vulnerability or a certain attack pathway, that is a local intelligence signal that should influence priorities. Even if the broader world is talking about something else, your own experience shows what worked against you. Vulnerability data can help you find similar weaknesses elsewhere in your environment, and threat intelligence can help you understand whether attackers commonly chain that weakness with others. This feedback loop is powerful because it turns each incident into improved prioritization, reducing the chance of repeating the same failure. It also helps you avoid prioritizing only based on theoretical severity. If you know a weakness actually resulted in harm, it deserves urgent attention and broader review. For beginners, the key is to treat incidents as evidence about what matters, not as isolated events that end when services are restored. Prioritization must also account for remediation feasibility, because the best priority list in the world is useless if fixes cannot be applied. Feasibility includes whether a fix exists, how disruptive it is, and how quickly it can be implemented safely. Sometimes the best immediate action is to apply a compensating control that reduces exposure while a longer-term fix is planned. Threat intelligence can influence this decision too, because if a vulnerability is actively exploited, the cost of waiting is higher and temporary measures may be justified. Vulnerability data can help you identify where a temporary measure would have the most benefit, such as systems that are exposed or widely used. The key is to make feasibility an explicit part of prioritization rather than an excuse for delay. Leaders can accept trade-offs when they are explained clearly, but they do not trust silent delay. For beginners, this is a reminder that prioritization is not only about what is important. It is also about what is possible right now and what reduces risk fastest. To bring this to a close, leveraging threat intelligence and vulnerability data is about turning two streams of information into a clear, defendable remediation plan. Threat intelligence tells you what attackers are doing and what they care about, while vulnerability data tells you what weaknesses exist in your environment and where they live. Prioritization happens at the intersection of attacker interest, internal exposure, and potential impact, with blast radius as a powerful way to focus on worst-case harm. Good prioritization avoids false precision by treating scores as inputs, validating context, and balancing stable risk drivers with changing threat signals. It also uses local incident outcomes as intelligence, feeding learnings back into vulnerability review so the organization improves after real events. Finally, it respects feasibility and uses compensating controls when needed to reduce risk quickly. When you can explain priorities in plain language, you make remediation more effective and easier to support, because leaders can see why certain work comes first. The result is not only fewer vulnerabilities on paper, but fewer incidents in reality and lower impact when incidents do occur. That is what it looks like when intelligence and data are used to drive real risk reduction.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.